Theory of relativity. According to this theory, in a moving object, time slows down relative to a stationary object. And this absolutely does not fit anywhere. It does not fit into logic or the basic postulate of the same theory of relativity, namely the equality of reference systems. In the special theory of relativity, if we take a stationary observer as a reference point, then time should flow more slowly for the one who is in motion. But in space, everything is in motion, and who can guarantee that the second is moving faster than the first? So we can equally well take the second, the one flying on a rocket, as a reference point. And in this case, the one waiting on Earth will be considered to be moving, and his clock will slow down. And both will quickly age, and at the same time each will become younger relative to the other, since it is he who will be in motion from the observer's point of view. This is some kind of nonsense, isn't it? And all this pile-up arises to explain the constancy of the speed of light, which is measured on a moving object and on a stationary object too. But we can imagine another mechanism for maintaining the constancy of the speed of light for a moving observer, if we consider a moving object as a local process in space, causing changes in space only near itself, according to the logic suggested by the observed nature. So a moving boat drives a wave in front of itself, or a car drives next to us and douses us with a compressed air front, and if we throw, for example, a baseball towards it, then the speed of the ball for the driver will be less than the sum of the speed of the car and the ball flying towards it, since the ball will slow down its movement upon meeting the high pressure front in front of the car, but behind the car. It can probably accelerate due to the suction capacity of the low pressure region behind the car. And why don't we imagine that a similar change will occur with space in front of the rocket? Space will contract proportionally to the speed of the object and slow down light in the same proportion. And when measured, the speed of light flying towards the oncoming object will not differ from the speed of light in a vacuum. Behind the rocket, space gradually straightens out as in the presented diagram, where the observer at point X is conditionally motionless. And the observer at point Y moves with speed v. And then we don't need to age the observer. After all, in global space, nothing will change for either the observer or the traveler, and the local compression and decompression of space will be noticed only by the light wave, and even then it is unlikely. The compression and decompression of space may have a different shape, for example, an elliptical shape, as in this presented diagram, or a completely different one. But the point is that it is more logical for us to admit a local change in the density of space for a moving observer than a change in time and the paradoxes associated with it. And we can also assume that each object in the universe holds an aura of space around itself, part of the space inside which light moves as usual. The same can be observed with any other waves, for example sound waves. Inside a supersonic airliner, passengers hear each other in the usual way the sound does not carry anywhere. The waves on the water in a basin, if you take it on an airliner, will be the same as in a basin on the ground. The same is with light waves, their speed for an observer in any place will be the same, since around him is his natural personal space, but the size of the personal space will depend on the Massachusetts of the object, its speed and its size. And how could it be otherwise? Otherwise, paradoxes like this arise. A rocket flies away from Earth at a speed of 9/10 the speed of light. An hour later a radio signal is sent after it, and for an observer on the ground the signal will catch up with the rocket only after 10 hours. But, according to probability theory, for an observer in the rocket, the radio signal catching up with him will be received in 2 hours. But then, based on the distance traveled by the rocket before receiving the signal, the speed of the rocket will exceed the speed of light almost 5 times. Not to mention that if we take a rocket as a reference frame, then it will not be the rocket that moves, but the planet Earth, and then, from the astronaut's point of view, time will slow down on Earth, not on the rocket, and by 9 times. And from the point of view of an observer on the ground, everything will happen the other way around. Time will slow down by 9 times on the rocket. According to my logic, no one will age 9 hours faster. The signal will reach the rocket in 10 hours according to Earth and to space-time, but the speed of light and the speed of the received radio signal will be, as always, about kilometers per second, at least inside the rocket.
What is compressed expanded in space? What forms an aura of personal space? It suggests itself that emptiness cannot compress or follow an object. Let it not be emptiness. Neutrons are the most suitable microparticles for forming space, called slow-moving neutrons, that scientists collected in a jar and carried in a jar from floor to floor in a laboratory.
Neutrons that are difficult to detect, they practically do not interact with matter, do not hold back light, do not ionize matter and exist in space in a hypothermic state close to absolute zero, forming protons, electrons, neutrinos, clouds of hydrogen and helium. These building blocks of the universe are found in abundance in cosmic radiation. Perhaps such neutrons fill space or even built into a spatial lattice in a cosmic vacuum, and they are also excellent candidates for dark matter. And excellent candidates for using their energy in future interstellar flights.